All right, second example in related rates. We got a triangle this time. This tells us that the base of a triangle is decreasing at a rate of 1 centimeter per minute, and the height of the triangle is increasing at a rate of 5 centimeters per minute. So we want to find the rate at which the area of the triangle changes when the height is 22 centimeters and the area is 110 centimeters squared. All right, so I'm just going to draw a triangle. It didn't tell us anything like it's a right triangle or isosceles or anything, so. And I'm just going to take notes on what they tell me. Okay, so the base is decreasing at a rate of 1 centimeter per minute. All right, so that's a velocity, a speedometer kind of thing. So that's how fast the base is changing. So I'm going to call that dB dt. All right, and our base is down here, the base of the triangle. Is 1 centimeter per minute. And the height is increasing at a rate of 5 centimeters per minute. So the height, we would draw this dotted line, that's the height. So that's also a rate, so I'm going to say dH dt is 5 centimeters per minute. Okay. All right, but the way that I wrote those two rates, I didn't take into account that the base is decreasing in size and the height is increasing in size. Those look like the same kinds of rates. All right, so we got to think of a way to denote that the base is decreasing and the height is increasing. And we're going to do that with a negative sign on the rate of change of the base, okay, because it's subtracting a centimeter per minute and the height is adding 5 centimeters per minute. Okay. And then they say, find the rate at which the area of the triangle changes. Okay, so what they want us to find is dA dt. Okay, and that's going to be units of area, so that's going to be centimeters squared per time per minute. And then they give us what I call the pause button information. Okay, it says precisely at the moment when the height is 22 centimeters and the area is 110 centimeters. Okay, so we're going to call that pause button information. Okay, so the height is changing. It's not always 22 centimeters, but this is where we're going to hit the pause on the video. The height is 22 centimeters and the area is 110 centimeters squared. Okay. So we've got lots of variables floating around here and lots of rates, and we need to write down an equation that would relate all three of them. We've got base, height, and area, so we're going to use the formula for the area of a triangle. Area equals 1/2 base times height, and then of course we're going to use our implicit differentiation, take the derivative of both sides with respect to t, so that we can get all these rates to fall out of the equation. All right, so of course derivative of A is just going to be dA dt. And then on the right, I've got B times H, so that's going to be a product rule. And I got to do something with that half, so I'm going to pretend that the half belongs to the B, and then H is the second function, and we're going to use our product rule. All right, so product rule over on the right. So we take the first function, 1/2 b, times the derivative of the second. Derivative of h is going to be dH dt. Product rule comes with a plus in the middle. And let's see, so first times derivative of the second plus the second, h, times the derivative of the first. And that's going to be 1/2 dB dt. All right, so we got a lot of variables in that equation. So let's kind of take, actually I'm going to rewrite that. dA dt, 1/2 b, dH dt. Just make this look a little better. We'll put the 1/2 in front of the h. Okay, so let's just see how many of these things that we know from the wording of the problem. Okay, so just going in the left-hand column where I took all my notes, dB dt they told us was -1 centimeter per minute. dH dt is 5. dA dt on the left is what we're solving for, so we're not going to plug anything in there. And my pause button information I can plug in now that I've taken the derivative, that the height is 22 centimeters and the area is 110 centimeters squared. Okay, well, there is no a in my equation to plug into. I have dA dt, but that's not the same as a. All right, what I really wish is that they had told me what the base of the triangle is when I hit the pause button. All right, but they were kind of being a pain, and instead they gave me the area over here on the left. Okay, so I'm going to have to figure out what b is. Okay, so we're going to go back to the original formula for area of a triangle, 1/2 base times height. Okay, and they told me that the area when I hit the pause button is 110. I wish I knew the base. I don't. But I do know that on the pause button, h is equal to 22. All right, so I'm just going to use that to solve for b. All right, so I've got the half and the 22. That'll make that an 11. So I've got 110 equals 11b. And I'll divide both sides by 11. And get that b is equal to 10. Okay, so when they hit the pause button, the height is 22 centimeters and the area is 110. That tells me that the base must have been 10 centimeters. And that makes sense that the area would be 110 there. 1/2 times 10 times 22. Okay, so dA dt is what we're looking for, and now I've been able to plug in everything into my equation on the right that I need. So I just need to do a little arithmetic here. So dA dt is what I'm looking for. I got 1/2 times 10 times 5 plus 1/2 times 22 times -1. Let's see, 1/2 times 10 is 5, times 5 is 25. And then this one's going to be a -11 when I multiply all that out. And let's see, 25 minus 11 is 14. Okay, and look at the Leibniz notation for your units. We're looking for units of area. In this problem, that's going to be centimeters squared. dt, time is measured in this problem in minutes. All right, and there's our rate of change of the area. All right. Okay, so like I said, we're just going to do 2 more examples whenever we get back together in class. See you then.